Hey guys, welcome to our interview series.
Join us as we dive into the world of STEM with inspiring interviews from industry experts.
Let's explore the innovations shaping our future one conversation at a time. I'm Sahasra, a sophomore who's been into robotics for more than 2 years.
And I'm Shakti, an 8th grader with 7 years of robotics experience.
We're the interview team for Super Sigma Robotics, and we're starting a series where we chat with STEM experts.
Our goal? To learn their journeys and inspire our community. Join us for some amazing stories and insights.
Thank you for joining our call today, Raj. We're thrilled to have you with us today. Before we dive in, we want to introduce ourselves really quickly. My name is Sahasra. I'm a sophomore at Vestview High School, and I'm the outreach lead for this team.
My name is Shakti. I'm part of the Drive team, and I'm also part of Outreach, and I'm an 8th grader at Stoller Middle School.
My name is Dhruv. I'm also part of the drive team and outreach for the team, and I also go to Stoller Middle School as an eighth grader.
Awesome. Good to meet you guys.
Yeah, it's nice to meet you too. We're ready to head into the interview. Shall we proceed?
Yes.
Okay, so the first question, we just want you to introduce yourself, like tell us a bit about your profession and everything.
Sure. So first of all, thank you guys so much for having me. I'm really excited to be here. Happy New Year. This is a good time to kind of kick off sharing a little bit about background and experience at the front end of the year with you guys. So yeah, my name is Raj Daftur. I originally hail from Michigan. I've been here in the Austin, Texas area for the last 4 years or so. Education-wise, I went to school and got my degree in mechanical engineering at Lawrence Tech University. It's an engineering and tech school in the Metro Detroit area. I also completed my master's of engineering degree from the University of Michigan. So we focused studying in the areas of energy systems and battery systems and fuel cells. So lots of energy and software and control systems there. And I also have my master's degree in business administration from Michigan State University. So that was also kind of an interest of mine from a school perspective. So kind of rounded those bases with business as well. Let's say career-wise. So career-wise, I've spent most of my time in the automotive industry working on electric and electrified vehicles. So primarily my work in this area was focused on systems and software and systems integration. So really understanding what is the physics of the vehicle or the subsystem? How do we translate that into software, which is, developing these features? And then how do we successfully integrate it into a product in a vehicle that achieves all of the objectives of that vehicle? So it could be performance. Hey, how fast can I go? How fast can I stop? It could be safety. It could be energy optimization and consumption. So, I've launched a lot of vehicle applications and programs during my time at General Motors and at Ford and Stellantis. And then I moved here to Austin and spent some time in the startup world working on Class 8 trucks. And today I work for a company called Fox Robotics doing autonomous robotics for loading and unloading of trailers, like products from trailers. So that's kind of a little bit about me and school and some of the work I've done.
Yeah, that was great. Next is I would like to ask what inspired you to pursue, your career in STEM? Take us back to when you first started.
Yeah, definitely. I would say there were a few inspirations. Probably the first one was just really loving the science classes I took in high school. And, some of like the projects I had a chance to work on as a freshman and a sophomore in physics classes, like mousetrap car project or egg drop project, and like starting to see for the first time, how do you take some understanding of science and physics and putting those together to solve some sort of problem. So things like that really piqued my interest. Also just the rest of the science classes you take, whether it was like biology or chemistry, physics, these things, like it gave you a way to understand the world around you, how things happen, how things work. And I just really found myself enjoying all of that, all of those courses and all of the kind of things you learn from there. Second, I was also part of like a FIRST robotics team in high school. And so kind of getting that experience of taking an idea to solve some sort of problem or challenge and stitching that together and making it come to life was like a really invaluable experience and led to me ultimately like wanting to go to school to pursue engineering. And I would say third was my dad. He's also an engineer. And so just growing up, seeing a lot of the cool projects that he was working on at work really kind of piqued my interest.
That's really cool.
Right.
Yeah.
So you were talking about how you were part of a first robotics team in high school. We'd like to like kind of know more about that. Like, what was the team, or was that your only experience with first, and like how long were you in first?
Yeah, definitely. So I participated in high school as a junior and a senior on a first team. So it was Team 469, Los Gorillas, outside of Bloomfield Hills, Michigan. And yeah, I think, like I said, the experience was like super invaluable. Like for the first time, kind of coming up with an idea and then like coming up with what the design should look like, and then actually making that design with your own hands and trying to put it together and figure out why it doesn't work or what the issues are, and like iterating through those and working through it. So I think it was like the first time you got that experience to go from like end to end, coming up with an idea to like, and then actually seeing it work was super interesting. And I think it pulled together and tied together like a lot of the core things you learn about in school. So it was that kind of first opportunity where you saw like the theory end come in with the practice end together. I think it was also just super interesting on working together with your team and your teammates on, hey, how do we tackle making this thing? And it's, not really that much time that you have to get the whole thing done. So you have some of these like real world constraints around you. Learning from a lot of the engineers that worked with us on the team, best practices, like how do you go about doing this? How do you go about using these development tools to make your ideas come to life? So I think all of those were super interesting and really kind of got me hooked into engineering.
Yeah, there's like a lot of things you can learn from like the first programs. It's really cool.
Yeah.
I think you kind of already answered this question, but like in what ways did your participation in the first program influence your job and your interests? Like,
Yeah, I think it really kind of gave a platform to explore this like science and technology and practice and, putting together something from scratch. Also, a lot of just like the debugging types of things where, you might not know what you don't know until you start working through it. And yeah, I would say that's kind of how that tied together.
yeah.
Yeah, so what is your favorite part of your job? Like every day, what do you like most about your job?
Sure. So I'd say my job today, as I've kind of grown throughout my career, is leading the department in the development of these autonomous forklift robots that we make. So there's a lot of like super interesting favorite parts of the job day to day. I think one is really, um, digging in and understanding, hey, we want to transform the market landscape of how goods are unloaded from a trailer when it gets to a warehouse, and doing that autonomously, which helps improve workflows, helps improve efficiencies and safety conditions. So understanding that environment and coming up with products and technologies that are nascent, not necessarily in the market today. So I think that's one very appealing aspect. Another aspect is leading my department and team through this effort. So, with any kind of development project, there's always challenges, roadblocks, things that you didn't foresee up front that end up materializing. But how do we effectively understand those? How do we navigate through those challenges and still get to a successful outcome? So I really enjoy that part of it. And also this like kind of strategic element. So crafting, right, where we are today, where we want to be in the future, what's that strategic roadmap for us to get there? And then what are the development engineering projects we need to start kicking off in order to be able to get to that successful next step outcome on the roadmap, which introduces something like the next new thing. So I'd say those are a few of the things that I really enjoy about the day to day.
Yeah.
So for your job, in robotics, what kinds of would you say are the skills that you need to kind of be able to pursue that? And how would you go about learning those skills or getting those skills?
Sure. I think there's so many different skills, but like probably one of the most important things from like an engineering or technology development perspective is really getting the first principles knowledge and understanding. So this is really digging in and committing to saying, I'm going to learn all the physics elements, the math elements, the software elements. How do those work at the core level? How can we actually learn the fundamental principles that then we can apply into solving other problems or building new technologies or advanced algorithms for robot perception systems? Like, you have to have first and foremost like an understanding of um, how do I describe these things through physics, and then how can I translate that into software or into a hardware solution that meets those. So having that good first principles understanding is important. um, I would say, just the aspect of teamwork is super critical skill set to always hone and learn over time, right? Most things in engineering and product development and technology development is not like a solo endeavor. You have to rely on the team around you, learn from them. Um, and then also, right, like learning some good problem solving methods and techniques. There's a lot of formal methods. There's this Japanese phrase used in the Toyota system called Genchi Genbutsu. It really means for you to go out and see for yourself. And that, like, philosophically, right, it's like, how can you solve the right problem if you don't really truly understand what you're solving for? So whether it's an issue that you're seeing on your current robot, you won't be able to solve it unless you can go out and understand what exactly is happening, how is it happening, what are the issues. Then you can work to solve the right problem. So that, and kind of anything that you're doing, really understanding the core of what you're trying to solve. So I would say these are some critical skill sets. As far as how you learn these, right? There's a few different pillars, right? One pillar is the classes that you're learning in school have this knowledge of the first principles. So, really digging in there and working through that avenue. I think programs like you're involved in with FIRST really help you get that hands-on experience, um, exploring in that perspective. And also, I think another way you really learn and grow is like pushing yourself into the uncomfortable zones, right? So um, you'll have tons of opportunities where you find yourself in a situation full of unknowns, or maybe you're uncomfortable or a little bit scared. And I think in my experience and career, those have been the areas where I've learned the most about what I'm working on. I've learned the most about myself and how I can navigate things. And I've grown the most. So, I think I'd encourage you to not be afraid of the uncomfortable, but try to jump in with an open mind and 2 feet, and see where things go, because that's where you can learn a lot.
Yeah, that's a great answer. Thank you. Can you tell us about a project or accomplishment you're proud of? Like,
Yeah. I would say in the last few years since I've been here in Austin in the startup environment, really proud of like what we accomplished. Coming to a startup environment, it's not like a big company where there's a lot of things rolled out for you. There's like a lot of processes and methods and approaches. So you really have to kind of come in and survey the lay of the land and understand, where are we today? Where do we want to be in the future? And how we're going to get there. And so, through both of the startup experiences, we've been successful in getting products to market with new technologies that have disrupted the marketplace that we're working in. And I think really proud about that, because we did it in super compressed timelines, introducing new things. And so, yeah, I think that's something that stands out in the past few years of proud projects.
Yeah, sort of like quick in between question relating to, how you run FIRST programs. What FIRST program were you in, or was it not like specified, like split into different, like it is now?
Let's see. So when I was in high school, I think we had like regular first robotics challenge program, and then we had like the first Lego League. I think those were the primary like pathways, which Lego League I think was generally not high school, it was like middle
Yeah.
school. um so I think that's what it was called.
Yeah.
Okay.
Yeah. Okay. Now, what experiences or oh wait.
Yeah.
Okay. Yeah. Sorry. What experiences or projects have significantly shaped and approached how you problem solve during your day-to-day jobs? And what lessons did you learn along the way that you would love to share with us?
Yeah, so problem solving is super important for STEM, but not just STEM, like for everything in your life. Like being able to critically look at something and come up with some solutions and test some of those solutions and see what works. It's just like it's a good STEM skill. It's also a good kind of life skill. Let's see. I think you really so like in automotive engineering and engineering as a whole in practice, there's this big focus area around like how do you come up with the root cause analysis for an issue or a problem. um, so we talked a little bit this phrase genchi genbutsu, going out and seeing and experiencing firsthand what the problem is, and then working through, right, um, what are some of the inflections of the issues. So like how do I understand what could be contributing to the issues? How can I then test some of those to validate, hey, these ones are contributing to my issue, but these ones are not? And then ultimately kind of solving the right piece. In industry, we use a lot of different techniques and methodologies to work through issue debugging and root cause analysis. There are techniques called like 5 whys, where you identify an issue and you keep asking yourself, why did this happen? Why did this happen? Why did this happen? That helps you kind of burrow. There are techniques like a fishbone diagram, where you kind of say, hey, what's the issue I have? This thing isn't working. What from the environment could prohibit this from working? And you try to brainstorm that. What from the human interaction or something that a human did might not be working? What's the data that might not be working? So you kind of break these pillars out, and then you go test and evaluate against those. Um, Automotive uses like this 8D method as well. It's another problem solving methodology. So these are some techniques that folks use in industry. In my time at Ford, one of my assignments, I spent a lot of time understanding field issues that were coming in from customers, and really diving deep into data to understand like what were the issues that they were experiencing, trying to understand where our software may not have been delivering on the feature sets, and then working through implementing solutions to those. So I think, going through that experience really gave me a strong footing in like, how do we do good root cause analysis? Also, in like a big company, taking issues from a customer, like the customer is not sitting right next to you, able to like explain exactly what they saw. You might be getting some issue ticket from a technician or from a dealership, and from that, with maybe some basic data that the car collects, you're trying to assess what's going on. So I would say that was one of the foundational experiences that really helped me build this skill set.
Yeah.
Great answer. Thank you so much.
So for your job, how would you say it kind of impacts our community? Like what kinds of things are you like, coming up with that could help?
For sure. I think I've always had a chance to work on products that impact the community and people and the way they interface with our products and go on with their daily lives, right? So in all the work in the automotive side and electrification, this foundationally impacts the way people conduct their daily lives, how they get themselves from point A to point B efficiently, effectively, safely. Car products are kind of core to most of our lives, right? We use them to transport ourselves, our families, whether in good times or in not so good times. So, I think the products have had an impact there. Also, being in the electrification arena, right, helping to contribute to more green and efficient ways of like how our products operate in the environment around us. How can we have or lessen our environmental impact through emissions. So a lot of the work in kind of like battery technology and development and software that I've done have contributed in those areas. Same right at Hyliion as we made Class 8 electrified semi trucks. These trucks move our goods and products that people in our community need and use every day into warehouses or into storefronts. And so being able to do that efficiently and in a green way that has a lessened environmental impact, I think is a contributor. And at Fox, in our automated robot application, we're streamlining the way workflows are, like how products are, like how goods are moved around in warehouses. So, these goods are ultimately used by consumers and people for executing their daily lives.
Thank you. You kind of already answered this question, but if there's anything you want to add on, so like what advice would you give to children like us who are interested to go into the STEM field?
Sure. I'll maybe reflect on a few things. So one, kind of like I mentioned earlier, is this like first principles understanding, really understanding your core disciplines really well. Being a good teammate, putting yourself in those situations where you can learn how to work well with others. Having honesty, integrity in everything you do, that's like super important. A lot of the products that I've had a chance to work on that people develop technologies for have safety implications, have compliance and regulatory implications. So, being up to board on doing things ethically in the right way is always really important. Again, right, like the pushing yourself to the uncomfortable zone, that's important to grow and learn. Knowing that it's okay to fail, like nobody ever succeeds at every single thing 100% of the time for everything that they do. And so, first is knowing that everybody fails. It's a part of your work, it's a part of life, but being able to learn quickly from the failures and incorporating those learnings into the thing you're going to do next just helps you become, better, faster, stronger the next time you tackle something. Prescribe to lifelong learning. I think that's super important. There's so many different ways you can learn. It's not all just, I went to school and I got a degree and that's the end of it. Throughout your life, you'll have different opportunities to learn from people around you, to take seminar courses, to learn through reading. So just prescribing yourself to being open to saying, hey, I want to continue learning. Like your journey for learning doesn't end after high school or college or some, educational milestone formally. It's being always open to seeing what's on the horizon and what's next. And maybe the last advice piece I'd give is I'm a big American football fan. And one of my favorite players, I don't know, for the last however many years was Tom Brady. And so Tom Brady has this quote that's, if you don't believe in yourself, why will anyone else? And so, learning to take everything you've learned and put it back into yourself and to have confidence in what you know and like portraying that every day. And sometimes there's an element of fake it till you make it, like, putting yourself out there, even if you don't feel confident, but putting on a face that I know what I know and I can tackle this and I can do it will help, give you the right kind of attitude set up to tackle a lot of the different challenges you may face. So maybe those are some of the tidbits I'd give for that.
Thank you. That was really helpful.
Yeah, that advice, you can kind of use it in STEM, but you can just use that kind of thing in your daily life too. That's not just something you can apply to STEM, which is
that's really helpful.
Amazing. Yeah. Thank you.
Sure.
What resources would you recommend to like lean into more to learn about robotics and STEM? Like maybe clubs or something like that.
Yeah, I would say for me, I was super into Science Olympiad team in my high school. I was a captain of our team. And so I learned a lot like that way. And also in that we had, these like project lab type of components or elements with Science Olympiad that were super interesting. First, I think obviously is a great one where you get this kind of merging point of technology and science and teamwork and mentorship from professionals in the field. So like things like these are super invaluable. Um, I think naturally through your coursework, whether it's in middle school or high school or once you get on to college, there's always these project elements. So like I was reflecting on earlier, like I remember very vividly, like as a sophomore making mousetrap car and doing egg drop, and it was like, oh, cool, like I can make something that like takes some of the stuff I learned in my physics class and start to apply it. So, you know, even in college, you're going to have courses that have these lab components or these project components, and those are super invaluable to seeing how we apply the theory part into practical projects. And I don't know, the last maybe resource is just yourself and like asking questions and being inquisitive. Sometimes it can feel intimidating, like asking some super expert like a question that you may think is really basic, but the only way that you have an opportunity to learn is by asking a bunch of questions. And while sometimes we think that folks are annoyed if we ask a bunch of questions, what I've actually experienced in real life is that people get really interested to talk and work with the person asking a ton of questions because it shows that you're really invested and you're trying to learn and you're trying to immerse yourself. And I think people really appreciate that.
Yeah.
I was surprised you mentioned you did Science Olympiad in high school as well. So you kind of did both of them. Was it at the same time or?
Um, yeah, so they were at the same time.
Really impressive.
That's how you
It was,
were.
yeah, it was fun, but a little busy. But like, I don't know, it was something uh, I don't know, found really exciting. So it was less of a like overwhelming task and more of a like, oh, this is something I'm invested in. So
Yeah,
That's
because
really
you're
cool.
interested. Yeah, we also have a couple of members on our team who have done Science Olympiad or did Science Olympiad as well. So
Another question we had was, how do you see robotics playing a role in our future?
yeah, good question. I think there's like so much evolution right now in the field of robotics. There's so many new technology developments. I think there's been a lot of advancements and things like perception systems and like assessing the environment and the world around us. And we're starting to really see how some of that technology is able to be integrated into different product offerings. So, we can look at advancements in like camera technologies and 2D and 3D LiDARs, which help us perceive and assess the environment around us. And now we're seeing how companies and people are taking those and implementing them. So many self-driving cars have LiDAR systems and advanced camera systems. Products like we work on in my company today use these perception systems to assess the real world environment and then improve workflows, take on challenging safety cases, make rapid decisions. So I think that there's a lot of unique and interesting things happening in robotics. I think there's going to be a lot of automation that comes in to help us solve like daily challenges. Whether it's, hey, I need to build something in a challenging environment that may be caustic to humans. Well, how can we still do that work? We could implement robotics. Hey, there's like a consistent workflow that's happening. How can we optimize that through automation and robotics? How can we tackle like efficiency challenges? So I think that these are some of the unique areas, and it really pulls in so many disciplines from hardware side, from mechanical side, electrical side, software side. So it makes for interesting problems.
yeah. So our last question of the day is, when you were in high school or even maybe younger than that, what would you have done earlier that maybe you wished you would have done to improve, your career? Like,
Sure. I wish I would have learned a little bit more about coding and software earlier. I think I probably didn't tackle some of those types of things until I got into college, like formally. So, so much of the things that we work on today are software based, and having some earlier exposure to that would have been, I think, helpful, something exciting to dive into. So I'd maybe say that's one area.
Okay. Yeah, those are all the questions we had.
Thank you so much.
Thank you.
You
Yeah.
gave very
Yeah,
good.
definitely.
We really enjoyed speaking to you.
Yeah, it was really great and it was really helpful for us to like
Yes.
learn about your journey and like your profession
Yeah.
and everything.
Okay,
Great.
now
Thank you for joining us on this journey into the world of STEM.
we hope you enjoyed our conversation and found inspiration in the stories shared.
Don't forget to like, subscribe, and hit the bell icon so you never miss an episode.
Stay curious and we'll see you next time.
Bye.
Bye.